Hello, hello, and welcome to Inside the Pod, first edition. My name is Valeria, and I am here with Theo. Would you like to introduce yourself?
Hello, my name is Theo. I've been working at Pod for the last year, and I work in the software engineering side.
So, Theo, tell us, what is Interstellar?
Interstellar is a simple way for engineers to deploy private developer networks. And that works for Pod, and it can work for other blockchains too.
Amazing. Tell me more. Tell me all the different technical capabilities.
Yeah, so let's say you're building your own one or two, and then you have a single node binary which you want to run. Let's say you have a container of it, and then that's enough. So you can pass that into Interstellar, and then Interstellar, depending on what kind of cloud providers it's integrated with, it can deploy it across the regions of those providers. So for Google Cloud and AWS, they have tens or hundreds of regions. So that makes it extremely easy to deploy there.
Maybe you can tell me a little bit about the testing process as it stands currently for L1s to set the stage of what we're going to be talking about today.
Yes. So I think it's an interesting problem when you start building an L1, because once you start on your computer, but then you want to test it across multiple networks and across multiple servers across the world. So the question is, how can you do that while at the same time you keep building and changing the protocol? The problem we have is that we have a single process, a pod node, which we want to run across the world, across regions all over all continents. And we don't care about orchestrating multiple of those multiple machines. We just care of running one single instance in a single server somewhere. So yeah, the thing is that we started with Kubernetes as everybody else, but then we realized that this doesn't serve us at all. Our solution, we call it Interstellar. And essentially it's something that we thought, okay, what do we really need out of this system that will help us internally test nets? And we realized that what we need is deploying single process, single instance across the world. So we need to somehow integrate with a cloud infrastructure. So Google Cloud, AWS, whatever it is. So we have that. And then we need a way to be able to provision the servers in order to install whatever kind of software we need, like Rust or whatever other utilities to compile. And then we need a way to be able to observe the instances, to be able to have monitoring and insights into what's going on, what kind of logs we have, how are the metrics looking, and things like that. And for that, we can use existing solutions, whether that's Google Cloud or AWS or even Prometheus and Grafana to self-host these things. So we can just integrate with those. But what we need is a central control plane, let's say, which will centralize all of these things. So that makes it very easy for engineers to just go and say, okay, I just need to deploy this version of pod into this number of instances across these continents. And so this is what Interstellar allows you to do.
It sounds like this is something the engineering team at Pod Network built internally to solve a problem that Pod Network was looking to solve.
Yeah, we think it would really help other teams too, because Kubernetes has the limiting factor in that it is usually within a single data center. And of course, there can be something like a federated cluster, but that adds so much more complexity to it. And if that's the main thing you need, then you shouldn't have to accept all the other complexity just to get the thing you need. So the core capability, which is to allow you to deploy processes and essentially Docker containers is what we're deploying across the world, is something that surely they will find useful. Yeah, we think it will be something that in a way simplify things for them so that they can actually go faster and for the infrastructure itself to actually be an obstacle, but in a way to get out of the way and allow the engineers to actually deploy and test whatever they need to do.
Awesome. Awesome. Thank you so much, Theo, for taking the time today. And I look forward to seeing you around.
Thank you too.
Thank you. Ciao.
Bye.